This is our light sheet microscope system. It's an LA Vision Ultra Microscope 2. It has a bank of lasers of different colours here that are sent through to the microscope itself. There's a sample chamber down here which is full of liquid, and a magnifying system here which collects the fluorescence from the sample and sends it upwards to a set of coloured filters in here which select different colours of fluorescence coming from the sample to be imaged on a camera system up here. Like the confocal, it's designed to produce optical sections from within a three-dimensional sample. It works with fluorescence and it uses lasers to excite the fluorescence. However, unlike the confocal, it's built onto a low magnification microscope frame, and this allows us to look at much larger samples, up to 1 centimetre by 1 centimetre by 5 millimetres in size, albeit not in so much detail as the confocal allows. So how does it work? Let's start with the sample preparation. Obviously our sample needs to be fluorescently labelled in some way, and then we need to optically clear it to make it transparent, so that we can get the laser light through it to excite the fluorescence and then let the fluorescence escape. So here is an optically cleared sample. This is a whole mouse brain in which the blood vessels have been fluorescently labelled. As you can see, it is almost transparent. We mount the sample in a holder. Here I'm using some aquarium sealant in a small plastic cup to temporarily hold the sample. We then place this into a frame which goes into the sample chamber on the microscope. The microscope produces a very thin but wide sheet of laser light which illuminates the sample from one or both sides. In this way, fluorescence is only produced at one level in the sample. We focus the microscope at the level of the light sheet and then move the sample through the light sheet, taking images as we go. In this way, we generate a 3D dataset. Here, we can see the light sheet switching from side to side to best illuminate both sides of the sample as it moves through its focus stack. Once we have our data stack, we can process it just like any other three-dimensional data set. Here are a few data sets from the system. This one shows early mouse embryos at different stages of development. This one shows the airways and blood vessels in a mouse lung. This one shows a particular type of nerve pathway in the mouse head. And, to show that we work with researchers across the whole university and on a whole range of samples, this is an ovary from a starfish that lives in the deep seas off Antarctica, where the environment is very cold, dark and stable. The researcher from the oceanography department wanted to find out if this starfish had a breeding season or reproduced all year round, so was wanting to count the number of different eggs at different stages of development in her samples.